example video, the quadratic inequality we're going to be trying to solve is negative x squared plus 10x minus 24 is less than 0. So the first thing to do is to remember that this quadratic expression here on the left-hand side of this inequality sign is a parabola. It's a quadratic function. So we are basically trying to find out values of x which are going to make this graph here, or where this graph here is actually going to be less than 0, where this graph is going to be less than 0. So the first step in solving a quadratic inequality problem is to sketch the graph. And what do we always do when we want to sketch a graph? Well, the first thing that we are going to do in this case, well, in normal cases, whenever we're sketching a graph, we always want to find out the stationary point. But in this case, as you'll see that whenever we're solving quadratic inequalities, we're not going to be interested in the stationary point or the vertex or the turning point of the graph. We're only interested in knowing the shape of that graph and where that graph cuts the x-axis. So those are the two things that we always need to know whenever we're solving quadratic inequalities. So in these situations, we don't actually need to know the vertex of the graph. We just need to know where the graph cuts the x-axis and the shape of the graph. So the first thing that we can deduce here is the shape of the graph. Because the coefficient of the x squared term is negative, we know that the graph is a sad graph. It's going to be upside down. Now the second thing we need to know is, where does this graph cut the x-axis? And where this graph cuts the x-axis, we're going to take the expression of the graph and equate it to 0, and we're going to have a quadratic equation. So we're going to say that negative x squared plus 10x minus 24 is equal to 0. Negative x squared plus 10x minus 24 is equal to 0. So this is now a quadratic equation. You can pause the video and attempt to solve this equation on your own, either using the formula, by factorizing, or by completing the square. In this case, I'm going to solve this quadratic equation by completing the square, just so you get used to the idea of completing the square. So to solve this quadratic equation by completing the square, we first of all complete the square for this function here. So we're going to have negative x minus 5 squared plus 1 is equal to 0. We complete the square for this, we take away the negative 1, we have x inside here. 10 divided by 2 is 5, 5 divided by negative 1 is negative 5, and then the rest of it, you check out my previous videos if you forgot how to complete the square. Anyway, upon doing this, we are then going to see that negative x minus 5 squared is equal to negative 1. We take the 1 this side. Then we divide both sides by negative 1, or multiply both sides by negative 1, and we are going to have x minus 5 squared is equal to 1. And this negative is actually not there because we've divided both sides by 1. So it's now positive x minus 5 squared is equal to 1. Negative 1 multiplied by negative 1 is 1. This entire thing multiplied by negative 1 is positive this thing. And then what are we going to do? We take the square root both sides, and we have x minus 5 is equal to plus or minus the square root of 1. Which just implies that x minus 5 is equal to plus or minus 1. Oops. Is plus or minus 1. Why? Because the square root of 1 is just 1. So in other words, x minus 5 is going to be equal to 1, and x minus 5 is going to be equal to negative 1. So x is equal to 6, and x is equal to 4. So these are the solutions to where this graph is going to cut the x-axis. It's going to cut the x-axis when x is equal to 6 and when x is equal to 4. Now we can sketch our graph. We can sketch our graph, and we know that our graph is going to look like this. Where this point here is the point 6, x is equal to 6, and this point here is the point x is equal to 4. This is the point x is equal to 4, this is the point x is equal to 6, and the graph is sad. The graph is going to look like this. And this graph here, this is y is equal to f of x, which is equal to negative x squared plus 10x, negative x squared plus 10x, and then this entire thing here, or minus 24. So this is the graph y is equal to f of x, which is equal to negative x squared plus 10x minus 24. So if we go back to our original inequality here, if this is f of x, we are looking for the region where f of x is less than 0. Is less than 0. So the question is, where is f of x? Where is f of x less than 0? Or where is y less than 0? Because remember that f of x is just the same thing as y. So where is f of x less than 0? Or where is y less than 0? Well, if we inspect our graph here, where's y less than 0? This graph is split into three regions. This region here, going down, if we extend this, the graph goes on and on and on and on down. This region to this side, because remember the graph just continues to go down. So we have this region this side, and we have this region here. This region here. So where is this region? Where is our y less than 0? Well, we know that over here y is equal to 0, over here y is equal to 0, because these 2 points, 4 and x, they make y 0. What about in between here? Well, in between here y is greater than 0. Take any x coordinate inside this region, your y coordinate is just going to be greater than 0. What about if you take x coordinates which are less than 4? If you go this side, well, if you go this side, all your y coordinates of the graph in that region are going to be less than 0. So this region is correct. If you look at this region as well, if you take any value of x that is greater than 6 and you go down, well, all your y coordinates are going to be less than 0. So you put a tick again. So we have two regions that satisfy this inequality here, and those regions are x is less than 4 and x is greater than 6. And these are our two answers to this quadratic inequality. X is less than 4 and x is greater than 6. And that brings us to the end of this video on solving this particular quadratic inequality. Until next time.